The light from the stars we see tonight has traveled for years across the vacuum of space before reaching our eyes. Uncovering the mechanics of the universe takes time. For almost our entire history, we have been bound to a single sphere of rock and water. But even while tethered to the ground, we have always looked upward, driven to reach into the dark. Between the years 2026 and 2028, that long buildup of ambition converges. In this brief window, we are launching the specific vehicles and systems designed to sustain human life outside our own atmosphere for years at a time. We are alive at the exact moment our species expands its footprint, moving from a presence limited to Earth to one that operates across several celestial bodies. For over 50 years, the dust of the lunar surface has remained perfectly still, undisturbed by human footsteps. Artemis 3, targeted for 2027, focuses on the logistics of a continuous human presence, establishing the habitats and systems required for astronauts to live and work on the moon. The vehicle making this possible is SpaceX's Starship. Standing 50 meters tall, it's a stainless steel skyscraper built to carry heavy cargo and crew. This diagram maps the mission profile. The crew launches from Earth in the Orion capsule, intercepting the Starship lander in the near rectilinear halo orbit to execute a precise transfer. The path then traces down to the harsh, shadowed terrain of the lunar South Pole. Because the Starship cabin sits so high above the ground, the astronauts will rely on a massive 35-meter mechanical elevator just to descend from the hatch to the lunar dust below. Mastering the logistics of living and working in this dark, freezing environment is a necessary precursor. If we can build an outpost here, we can survive the journey to Mars. But the hardware touching down on the rock is only half the equation. We must also conquer the immense, empty void separating our worlds. To maintain constant contact, SpaceX is deploying thousands of second-generation Starlink satellites. By linking these nodes with lasers, they are weaving a continuous nervous system of data that bridges the miles back to Earth. Operating alongside this commercial grid is Starshield. It functions as a secure, military-grade surveillance architecture, silently observing and protecting critical orbital assets. Protecting our expansion requires looking outward as well. In 2028, a Falcon 9 rocket will deploy the NEO Surveyor telescope. Instead of looking for reflected visible light, this observatory uses infrared sensors to detect the thermal signatures of dark, hidden asteroids that might cross our planet's path. Before we can safely settle other worlds, we must construct this invisible shield of communications and defense to guard the home we leave behind. Our reach now extends billions of miles past the Earth and Moon, stretching out to the massive icy rings of Saturn. In 2028, a Falcon Heavy will launch the Dragonfly mission towards Saturn's largest moon, Titan. Titan is a deeply alien world. It possesses a crushing atmosphere, 4 times denser than Earth's, with hazy orange skies and vast surface lakes filled with liquid methane. Navigating this terrain requires an entirely new vehicle. Dragonfly is a car-sized, nuclear-powered drone engineered specifically to fly through this thick blanket of hydrocarbons. It will soar from dune to dune, drilling into the organic-rich surface to search for the prebiotic chemical structures that act as the building blocks of life. Deploying these advanced machines to the deepest corners of the solar system gathers the physical evidence needed to explain how life actually originates. Over a span of just a few years, we are coordinating the assembly of skyscraper-sized steel ships, weaving vast orbital networks of laser light, and dispatching nuclear-powered drones into the deep. Every launch and orbital test is a calculated step toward a single objective, establishing a permanent logistical chain between Earth and the surface of Mars. The cosmos is vast, silent, and entirely indifferent to our presence. We will likely never uncover all of its mechanics, but the pursuit of those answers is beautiful in its own right. It is an extraordinary paradox. We are a fragile species, forged from stellar debris, now engineering the physical hardware required to maintain a presence across our solar system. Our drive to excel isn't just human ambition. It is the universe itself finally attempting to understand its own nature.